Right, welcome back Year 7 to your Osmosis Lesson 2, and 24 hours later let's see what's happened. Now it's a very simple experiment, but there is good ways to do this. So I'm going to take my salt chip out and have a cloth somewhere and just mop off any excess water. And I'm going to measure this now, so I'll try and show you this to the camera. Put it to there like so. I'm making that close to 53, 4, maybe 54, 53. So my salt one, 53, has gone down slightly. It's interesting. And then the pure water one. Now, again, in class we would use a cork borer to make these, so they would be more regular shape, but this will do. Now that one, I don't know if you can see under the camera, is 50, it was literally on 55. That's changed significantly. So that one is now 55. And so that's my raw data. So what do we do with this data? So let me move my workstation out of the way. Now if you've got 3 chips, as I suggested yesterday, what I'd like you to do, of course, is to measure all of them and take the average. Some will have changed more than others. And you then want to create a second table, which again I shall pop up here. So we have potato, and draw a line down there, and we're going to have the pure water, we're going to have the salt water, and we're going to have the difference. And again we have to put in the measurements because that's good science. And so here, down here, 50 to 55, and that's gone up. That's gone up by 5, so that's plus 5. Now this one, gone 55 down to 53, has gone down by 2, so that's minus 2. So they've changed shape because of the water they've been placed in. And what would be nice to do then would be to do the percentage difference here. And this one was 5 out of 50. And you can do that in your head, but again, 5 divided by 50 equals 0.1, 10%. And this one, it's 2 out of 55. So 2 divided by 55 equals, and then times by 100, make a percentage. And that's going to be 3.6, say 4% difference. And let's put our pluses in. So what have we found? It was quite significant. Frame my table off. Now of course you'll be doing this with a ruler, please, and not the stupid cag-handed way I've just done it there, if you don't mind. I actually just walked into the camera. And so what I want you to do then, well, we've got between the two of these, 10% plus and 4% minus is actually a 14% difference. So between pure water and salt is a total of a 14% difference after 24 hours. And the question to you now is, why is that? Because if this is true, it means that any item placed in pure water will swell. That would mean that when you have your bath at night, if you stay in the bath for 24 hours, you might get 10% bigger. And if you sat in a salt bath, you get 4% smaller. Please don't try that at home. You have skin, which is fairly impermeable to these. But it is true that if you put items into salt, they will shrink. And I want you now then to research the whole concept of osmosis. What is it? Go and write down in your book the word osmosis and write down a definition of it. And try and do it with some diagrams. Now the BBC Bite Size do this superbly, and it is well worth your time going and looking at it. And this is why it's important for cells. The cells in your body have to have a constant concentration of sugar and salt around them. And when you don't get a concentration of sugar and salt that's correct, people become very ill. And that's where diabetes comes from, because some of those people have got a sugar imbalance. And it causes a sugar imbalance will cause their cells to shrink, and that makes them feel very unwell. Enough for today. See what your experiment comes out with. I'd love to see some results. By all means, email them to me on the school thing and have a go at doing this. Again, science done practically is how you learn. It's much better than just science out of books. So enjoy this, please. Thank you very much.